Math! So what we got here is something way more complicated, right? Now, again, this doesn't have to be just two terms. You could have plus, something else, minus something else. So I'm just doing two terms because that's the amount of space I have on my wall, right? So what we're going to do is take out the GCF from both these terms and put it on front and see what we end up with. Over here, we got 2x cubed 6x to the power of 5. And let's deal with the 2x cubed and 6x to the power of 5 right off, right? So between 2 and 6, we can take out a 2. Between x cubed and x to the power of 5, we can take out x to the power of 3. x cubed, right? Now, don't let them putting in anything, a plus 1 cubed and a plus 1 to the power of 4, don't let the stuff throw you off. When you have brackets like that, that's considered just to be a box, whatever it is. So you have a box cube and a box to the power of 4, so whatever is in there can come out, depending on the lowest link in the chain, right? That's 3 of them there, and you got 4 of them there, so you can take out 3 of them. So that's just going to be, on this side coming out, is going to be a plus 1 to the power of 3. And then we're going to have to deal with the denominator, right? We got 25y cubed, and we got 15y to the power of 5w. So you can take out a 5 from both of them. The smallest link in the chain for the denominator, that's y cubed and y to the power of 5. Can you see y to the power of 5? So you can take out a y cubed, and that one has a w, that one doesn't have a w, so you can't take out a w. So what comes out is 5y cubed. Now we're going to have to try to figure out what's left in there after we took out all that stuff. So we have 2x cubed. We already have, we want 2x cubed a plus 1 to the power of 3 for the first term inside the second bracket. Well, that's all the stuff that we got already out. So if we take the numerator over there and multiply it by the first term here, all we need is a 1 because we just have to reserve the spot. Because everything's there that we need it to be over there, right? Agreed? All you do is just take that and multiply by 1, and you have the first term, the numerator up top there. For the denominator, we have 25y cubed. That's what we need to create, right? 25y cubed. We have 5y cubed, so all we need in the denominator here is just a 5. So what we've got to do now is recreate the second term, right? Again, we're going to take a look at this and see what we need. We have, what do we got? 2x cubed, we have, let's bring it over here. We've got 2x cubed, and we have 6x to the power of 5. So we need a 3 on this side. We need an x squared on this side. We need a z squared because we didn't take out a z squared. There wasn't a z in that term. So in here, we're going to need, we got 2, we need 3, x to the power of 2, z to the power of 2, and a plus 1 to the power of 1. And for the denominator, we have 5y cubed. We got 15y to the power of 5w. So we need a 3, and we need a y squared, and we need a w. Now this bottom part is that top guy factored. And we could have simplified this a little bit further because we've got 3 over 3 here, so the 3's can kill each other. Always try to simplify your equations. And when it comes to GCF, it's a super powerful tool. You're going to end up using it a lot. It's, it comes up again and again and again. And when we go on from quadratic equations to polynomial functions, higher level functions than just x to the power of 2, where we're getting, all kinds of weird curves, you're still going to use the GCF because it's, it simplifies your equations. It allows you to, again, use the property of 0 where you have, multiple things multiplied to give you 0. The only way that's possible is if at least one of them is equal to 0, and since you don't know which one you solve for, all of them equal to 0. Okay? And this is GCF, super powerful. Learn it. What we're going to do is now go on to simple trinomial equations and factor those things.